In this lesson, we are going to learn how to find the derivative of functions using the limit process. Okay, so let's look at what that means. So let's say I have a function y equals f of x. Okay, and then I want to find the derivative of this function here. We can write this as y prime or f prime of x or dy over dx. So for the limit process, it says that the derivative of the function y equals f of x will be the limit as h approaches 0 of the function f of x plus h minus f of x divided by h. Okay, so that's the definition of derivatives. Okay, when we are using the limit approach. Okay, so we are going to understand this by trying our hands on some few examples. So let's look at the first example here. So in this case, we have f of x to be equal to 2x minus 1. Okay, so you have to find the derivative of this function here. So let's look at what you are going to do. So all we are going to do is that we are going to take this function here, and then wherever we see x, we will put f of x plus h there. Then from there, we will come and what apply the limit definition of what derivative. So we are going to have f of what x plus h, okay, to be equal to 2 into bracket x plus h minus 1. Okay, you can choose to simplify this here. Okay, then you will have 2x plus 2h minus what 1. So this is what you have for f of what x plus h. So we then go back to the limit definition, then do the calculation. So we will have f prime of x to be equal to the limit as h approaches 0. Okay, and then we know f of what x plus h to be 2x, okay, 2x plus 2h minus 1, okay, minus f of x, and then we know f of x to be 2x minus 1. Okay, this is what you have. So all this divided by h. Okay, so actually what you are doing here is that we are supposed to substitute h equals 0 into this expression that we have here. Okay, we have to put h equals 0 into this expression that we have here. But when you put h equals 0 here, we are going to have 0 over 0, and then this is not defined. Okay, so in that case, that means that we can't find the derivative of what the function given, but it is possible we can actually find the derivative. Okay, so let's look at how we are going to do it then. So to do this, I'll further simplify what you have on top here. So that'll be the limit as h approaches 0. Okay, so you're going to have 2x plus 2h, okay, minus 1, and then distribute this negative to the values in the bracket. So that'll be minus 2x plus 1 divided by h. So this is what you have now. So let's look at what you can do. So in the numerator, you can cancel out these two values here, okay, because you have 2x minus 2x, so that gives us 0, and then also you have minus 1 plus 1, so that also gives us what 0. So let's look at what is left now. So you're going to have the limit as h approaches 0 to be 2h divided by h. Okay, so over here, what we do next is that we will cancel out the h. Okay, so and then you're going to have the limit as h approaches 0 to be what 2. So you see that at this point here we don't have any h here, okay, attached to this 2 here, where we can substitute h equals 0 there. So we therefore see that the limit of the function will be what 2. So sorry, we will therefore see the derivative of the function is 2. Okay, it's not limit, sorry about that. So this will be the answer after finding the derivative of what this function here. So all you have to do is to follow this process, and then you'll be able to find the derivative of a function using the limit process. Let's take another example. Okay, so for the next example, we have f of x to be equal to x squared plus 3. Okay, so you have to find the derivative of this function using the definition of what derivative according to limits. So we are going to have f prime of x to be equal to, sorry, the limit as h approaches 0. Okay, for f of x plus h minus f of x, all divided by h. So we already know our function f of x, so we have to find f of what x plus h. So you have f of x plus h to be equal to x plus h squared plus 3. So let's simplify what you have here. So we are going to have something like x plus h multiplying x plus h plus 3. So when we simplify this, we are going to have x squared plus xh plus xh plus h squared plus 3. So that gives us x squared plus 2xh plus h squared plus 3. So that's our f of what x plus h. So now let's go and then apply the limit definition. So we are going to have the limit as h approaches 0 to be x squared plus 2xh plus h squared plus 3, okay, minus x squared plus 3, all divided by h. Okay, so what we do is that when you substitute h here directly, we will not get our answer. So you have to further simplify and then take out the h so that you can get our answer. So let's continue. So we're going to have the limit as h approaches 0 to be x squared plus 2xh plus h squared plus 3 minus x squared minus 3, all this divided by h. So let's simplify what you have on top. So we're going to have the limit as h approaches 0, and then over here you can cancel out some terms here. So you have plus 3 and then you have minus 3. So we'll cancel out each other, and then we have x squared here and then you have minus x squared here. So that will also cancel out. So then you are going to have 2xh plus h squared, okay, all divided by h. So over here you see that we still have h here. Okay, so when you substitute h equals 0 here, you are not going to get our derivative. So let's further simplify. So what I'll do is that I'll factor out the h, okay, for the numerator. So that will give me the limit as h approaches 0. Then I'm going to factor out h in the numerator. So I'm going to have h into bracket 2x plus h, all divided by h. So over here, we can cancel out this h. So we are then going to have the limit as h approaches 0 for 2x plus h. So at this point, you can substitute h equals 0 here. So when you do this, you are going to have the limit as h approaches 0, then that will be 2x plus 0. So then you are going to have the derivative to be what? 2x. So therefore, the derivative of the function x to the power 2 plus 3 will be 2x. So this is how to apply the limit approach to find the derivative of functions. We are going to be solving more examples under this topic. So please make sure you subscribe and turn on your notification bell so that you can receive the notification when I upload new videos. Thank you very much.